Now let's see binary codes. So what is coding is, if you have some information, whatever it is, like A, B, C, D or 0, 1, 2, 3, or a picture or a video, all these are informations, right? So if you have some information and if you want to store it in the computer, everything has to be converted to zeros and ones. So that is why we use binary coding. So it is called as encoding and decoding. Encoding means converting it from one form to other form, and decoding means getting from that form to the original form. So for that reason we use generally codes. So codes are like, we take some information and we represent it in some other form. They are called codes, and later we take that codes and again we get the information back. Why should we do the conversion? Because we, the human beings, we can understand certain languages, but then coming to computer, it has only two states, 0 or 1. So whatever you speak or whatever you do or whatever you want to store, everything has to be converted to zeros and ones. That is why we are going for binary codes. Why binary code? Because it has only two states, 0 and 1. Now binary codes are of two types. One is alphanumeric codes and other is numeric codes. So what is alphanumeric code is, you have both the alphabets as well as numbers. So generally any information contains two things. One is alphabet as well as numbers and some special characters like dollar, cap, hash, like this, right? So all these characters as well as numbers, they are generally traditionally have been represented using two forms. One is ASCII and other is hexadecimal. So ASCII was using 7 bits and hexadecimal was using 8 bits. So don't worry about this, they are not in the syllabus. I mean, there will be no questions asked from them, so we shall not go in detail about those. Now come back to these numbers, how to represent the numbers. So we have what are the numbers? We have 10 numbers, isn't it? It is called as decimal. Now we take a decimal number and we code it into binary, that is called as binary coded decimal. Therefore, in order to represent the numbers, the most popular representation is BCD, binary coded decimal. We take a decimal number and we convert it into binary form and we save it. And generally BCDs are of two types. One is weighted and other is non-weighted. What I'll do is I'll take examples later and explain you, but here just I want to walk you through all the topics. Later I'll take each topic and explain. So even if you don't understand in this, don't worry, I'll take examples. Now see this. Weighted means if you represent a number in this form, then we can give a formula about what that actual number represents. That is called as weighted. For example, 8241 is a weighted code. So what I mean by 8241 is, watch it. If 8241 is the weighted code, if I write something like 0011, what it represents is 1 into 1 plus 1 into 4 plus 0 into 2 plus 0 into 8, which is nothing but 5. So we have a formula here, right? So every bit is multiplied by its weight and then added together. Then we are going to get 5. Got it? So that is the meaning of weighted codes. The same thing is applicable for all the codes. There are various weighted codes. You too can come up with your own. But then there are some standard codes which are being followed for a long time. Just as convention, we are following them. And moreover, some of the codes, they have got some beautiful properties. And these properties are making them more useful in some of the applications. Okay. Now if you watch it, 8421 is a weighted code like that. 3321, 2421, 84 minus 2 minus 1. Weights can even be negative, just like in 2's complement. Or 631 and minus 1. Now all these, except this 8421, the remaining whichever I have written here, they fall under a category called as self-complementing codes. So what is a self-complementing code is? See this, self-complementing code means, in self-complementary code, the code of a decimal digit and the complement of 9's complement of the digit are 1's complement to each other. I am very sure you didn't understand anything from the definition. That is why I have taken the example here. See this. Let us say this is the weighted code and the weights are 6, 3, 1, minus 1. So in this number system, so in this coding 6, 3, 1, minus 1, what does the number 0, 1, 0, 1 represent? It is 3 minus 2, which is nothing but 2. Therefore this particular pattern 0101 represents my 2, right? And now you take the ones complement of this pattern. If I take the ones complement of this pattern, I get 1 0 1 0. Now what does this one represent? 6 plus 1, which is 7. Therefore when you are taking the ones complement of a code in this self-complementing codes, you are actually getting the nines complement of the number represented by them, isn't it? What is the nines complement of 2? 9 minus 2, which is 7. What is ones complement of this? Therefore when you take the ones complement of the code, we are getting the nines complement. So don't worry about it. I have taken only one example. Later I will take a lot of the entire numbers represented, and I will again explain it. So for now, think about it. Self-complementing code means in this code, if you represent a number and if you take the ones complement of it, you should get the nines complement of the number, right? I'll take more examples and explain. Don't worry about this particular topic. And now the next type of codes are non-weighted codes. So what are non-weighted is, we cannot assign any formula like that. So here we are able to assign a formula like every bit multiplied with its weight and added together is going to give us the actual number that particular pattern is representing. But here we don't have any such formula. These codes are actually we have to remember them somehow. So this is gray code. One example is gray code. So what is the beauty of gray code is, the distance between two words in this gray code is 1. What is the distance? I'll come to this point later, or if you see this, I'll explain it. See this? If I have 0 0 0 1, it is very important, try to understand it, and then 0 0 0 0, what is the distance between these two codes? Now if you observe it, in order to change from this code to this code, the number of bits that have to be toggled is 1. Therefore the distance is 1. If I write 1 1 0 0, if I have to change a code from here to here, the number of bits that have to be toggled are 1 2. Therefore the distance between these two is 2. Got it? Now the beauty of gray code is, if you have the numbers represented in this gray code, if you take any two successive numbers like 1 and 2, the distance between these two patterns used to represent 1 and 2 will be 1. That is called as unit distance, which means the distance between successively represented numbers in this code is always going to be 1. So why is it useful is, especially in counters, when you are changing from one pattern to the other pattern. In counters we go from 1 to 2, 2 to 3, 3 to 4, right? And now when you are changing from one pattern to the other pattern, it is always easier that if you can change just one bit and get the next number instead of changing 2 bits. If you have 2 bits to change, then what happens is, because of some delays, one bit may get changed faster and the other bit may get changed slow, then you'll end up with an intermediate representation which is not right. Okay, what I mean to say is, sorry for that, I should have taken an example. Watch it now. See, what I'm trying to say is, if you take normal number system like BCD, I'll again come to that BCD. So 0 0 0 0, this is 0 representing as 0, right? And then 0 0 0 1, this number is representing 1, 0 0 1 0, this number is representing 2. So when I am counting the number of clocks using a number of clocks using a counter, then to change from 0 to 1, number of bits that have to be changed is 1, so it is easy. To change from 1 to 2, the number of bits that have to be changed is 2. What are they? This one has to be changed from 0 to 1 and this one has to be changed from 1 to 0. Now what is the problem with that is, when these bits, 2 bits have to be changed, let us say one bit got changed early. See, 0 0 0 1, 2 bits have to be changed, this one and this one. Now because of the delays, uneven delays, let us assume that one bit got changed early, which means you get 0 0 and then 1 0 1 1 here. This bit has changed early. Therefore after 1 you might see 3 temporarily. Later immediately this one will change to 0 and you will get this 0 0 1 0 and immediately you will see a 2. That is not an issue. But then for some time you are going to get into an unstable state. So just to avoid this, gray code will be useful, because distance between 0 and 1 it will be 1, and from 1 and 2 this will be 1, and from 2 to 3 it will be 1. Therefore you will not see any unstableness there. Okay, and now XS3 code. So there is one more code popular which is called as XS3. It is also a sequential code as well as self-complementing. So what is sequential code and self-complementing? I'll explain you when we get to that topic. So here I have just given you a brief overview about what are the various codes we are using to represent numbers and what are the advantages of them. I'll get into each one of them in detail with examples. I'll make the topics clear. So let's move on.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.